we're going to go ahead and look at the notes to identify function, not a function. So we're going to start off by identifying the parts that I'm looking at when looking for a function. So I'm looking at my input and my output. Another way to explain input is my x. This is also known as my independent variables. This is also known as my domain. My output is the same as my y, which is the same as my dependent, and this is also known as my range. Okay. So a function is a relation where every input, or x, corresponds to only one output, or y. So I don't care what my output is, I just care that every input only has one output. So it does not matter what the output is, I only care that, it only matters that there's only one. So some ways that they could ask you this is, which represents y as a function of x? It's just asking which is a function. Which does not represent y, as a function of x, is just asking which is not a function. So it might sound a little weird, but it's just asking which is a function, or if it's asking which does not represent y as a function of x, it's just which is not a function. Okay, so let's go ahead and look at some specific examples. So we're going to identify if these are functions or not and explain why or why not. So let's go ahead and look at my ordered pairs. So going back to my definitions, I know that I just want to see that every input has one output. So what are my inputs? My inputs are my x's. So my inputs are the x's. So I'm going to go ahead and identify, okay, well, which ones are my x's? So it's always x comma y. So since it's always x comma y, I know I'm looking at my first number. So 6 is my x for my first ordered pair, -3 is my x for my second one, -8 is my x for my third, and 6 is my x for my fourth one. So I want to see, does each one of these inputs only give me one output? So basically, does each x only come out once? So if I look here, I have 6, -3, -8, and 6. These two repeat, so that means that I need to check to see, are these x's giving me two different outputs or two different y's? So here, my input of 6 gives me the output of -4, okay? And then over here, 6 also gives me the output of -1. So this would not be a function. Why? Because 6 has two outputs. So 6 gives me both -4 and -1. So since it gives me two outputs, it is not a function. So let's go ahead and look at my second example. So I'm doing the same thing. I'm looking at my inputs or my x's. So my input here would be 2, -2, 0, and -3. So none of these x's repeat. 2, -2, 0, and -3. These are all different. 2 and -2 are not the same number. So these are different x's. So this one is telling me 2 gives me an output of -4, and I don't have 2 anywhere else here for my inputs to give me a different output. -2 gives me an output of -7. It has no other output. 0 gives me an output of 2, and -3 gives me an output of 8. So none of these inputs repeat. So this would be a function. So this would be a function, and my explanation would be each input has only one output. So let's go ahead and look at the tables. So the same way that in the ordered pairs I was looking at my x's, I'm looking at my x's for my table as well. So looking at my x's are 1, 0, 3, 2, and 4. So none of these inputs repeat, and because none of these inputs repeat, I know that they are a function. So looking at this one is a function for the same exact reason that these ordered pairs are a function. So this one is a function because each input has only one output. So I'm going to go ahead and look at this second table. So looking at this second table, I'm going to look at all my x's. So my x's are 1, 3, 9, 7, and 9. So here I have 9 twice. So I have the input of 9 come out twice. So here it's saying my input of 9 gives me 6, and then over here my input of 9 also gives me 10. So I can't have the same input give me two different outputs. So this one is not a function because 9 has two outputs. So 9 has the output of 6 and 9 has the output of 10, so that means that it's not a function. Okay, so let's go ahead and look at the back. So now we're going to check to see how we can tell if a mapping is a function or not a function. So going back to the front page, we know that it's a function when every input has a single or just one output. It doesn't matter what the output is, it matters that there's only one. So we're going to go ahead and check to see how many outputs each one of these inputs have. So x, of course, is my input. So I want each one of these inputs to only have one output. So that means that it can only have one line leaving it. So 5 has the output of 1 and just 1. 6 has the output of 2 and only 2. 7 has the output of both 1 and 3. So 7 has two outputs. Therefore, this is not a function. And my explanation would be because 7 has two outputs. So 5 only had an output of 1, 6 only had an output of 1, but since 7 had an output of 2, the whole thing is not a function. So let's go ahead and check if our other mapping has only a single output for every input, or do any of them have more than one. So 0 has an output of 2 and only 2. 0 is not going to any other number, so it only has one output. 1 has an output of 2 and only 2. 1 is not giving me two outputs. It's only giving me the one single output, which is 2. 2 only gives me another single output because it only has one line leaving it. So even though they're all going to the same number, that's not what I'm looking for. I'm only looking to see how many outputs does each input have. So each input only has one line leaving it, so therefore it only has one output. So it is a function. And the reason would be each input, or x, has a single output, otherwise known as y. So each input x has a single output y. So let's go ahead and look at graphs. So if you remember graphs, we have something called our vertical line test. So when we're looking at a vertical line, this direction right here, up and down, is a vertical line. So I'm going to imagine a vertical line passing through my graph. And when it's passing through my graph, at any point on the graph, it cannot cross more than once. If it crosses more than once, that means it has more than one output. So just like how in the ones before, the mappings, the tables, the ordered pairs, I only wanted it to have a single output. Therefore, I only wanted it to cross a single time. If it crosses more than a single time, it fails the vertical line test. It has more than one output. So I'm going to imagine some vertical lines passing through. So I'm going to go ahead and mark them on my paper. So imagining these vertical lines passing through. At this first vertical line, it only crosses once, so that has a single output. Here, though, it crosses twice this vertical line. Therefore, at this spot, it has more than one output. It fails my vertical line test. Therefore, it is not a function. Okay? And since it's not a function, my explanation would be that it fails the vertical line test. It crosses at 2 points and has more than one output. So the fact that it crosses at more than 1 point tells me that it has more than one output. So I'm going to go ahead and look at the other graph, and I want to again imagine a vertical line passing through my graph, and it can only cross once. When it only crosses once, it's telling me it only has one output. If it crosses more than once, it has more than one output, it's not a function. So again, it's going through, it's only meeting at this 1 point, at this 1 point, at this 1 point, at this 1 point, at this 1 point. So as I'm passing through, it's only meeting at 1 point. It's not meeting anywhere else. It's not meeting down here. It's just this one single line. So therefore, it is a function. If you want something more visual, we can draw a couple of vertical lines just randomly anywhere. And if we look at these two random vertical lines, it only crosses once at this point. It only crosses once at this point. So there is no point on my graph where it crosses more than once or has more than one output. So it is a function because it passes the vertical line test, which means that each input, or x, has a single output, or y. So we are done with the notes. So now if you see at the very bottom it says these are your notes. Now do the X ticket on your own to raise your 8.5G test grade. So I'm not doing the X ticket with you. You need to take that out of the folder and do it on your own. And hopefully you will get it right and be able to raise up your test grade for this topic.